you to graph a circle, and then everybody was like, I don't know what to do. Well, I didn't say it was a circle either. I just gave you an equation, and it sounded like a lot of people didn't know much about graphing circles. So the equation of a circle is in the form of x squared plus y squared equals r squared. And then there's also a form of that has transformations. We're not going to really need this form today or anything, but I do want to show you that form that has transformations where you would translate left or right. Circles do not have stretches or shrinks, because if I take a circle and I like stretch it vertically, can't really draw it. Or can't really. If I were going to take the circle and stretch it vertically, is it going to be a circle anymore? Nah. Same thing with like stretching it horizontally. It's not going to be a circle anymore. That's something else that we will study in chapter 10. Reflections, like, I guess you could reflect it, but we don't really typically do any of that stuff. We just have either the circle that has a center at 0, 0, or a circle that has center somewhere else. We're going to use this one that has center at 0, 0, because we're using 0, 0 for the middle of our unit circle. Theta is going to be an angle. Theta is going to be an angle in standard position, and then there's a point, xy, somewhere on the circle. And that xy point is where your terminal side of the angle goes. So we have our initial side here, and we have our terminal side here. And then theta is that angle. To get to this point here, we go x units to the right, and we go y units up, and that's how we graph that point. But when we do that and we go x to the right, y up, if we look at our radius that connects back to 0, 0, we now have a right triangle. And I called it radius instead of like hypotenuse. I called it radius because of the circle, the r is the hypotenuse. So r is the distance from 0, 0 to this point. And you can use the distance formula. It's written over here. So the distance formula would be square root of x squared plus y squared, which should look like some other formula that you know that looks like this. A squared plus b squared, and the square root of that is c. What formula does that look like? Pythagorean theorem. That's it says it right there. That's what we're using to find the radius. We're just using Pythagorean theorem. Now, because I am putting it on an xy chart, we can now have our sine and cosine and all of our trigonometric ratios values using x, y, and r instead of using opposite, hypotenuse, adjacent. So I'm not using those words anymore. I'm now using x, y, and r. So if you look at this picture here, and theta is the angle of the rotation, x is going to be which side? That's the adjacent. Y is going to be the opposite because r is always the hypotenuse. But I'm not going to use adjacent, opposite, and hypotenuse anymore. I'm going to use x, y, and r. So what I've done is I've set up SOHCAHTOA using x, y, and r. Sine is y over r. That's still the opposite over the hypotenuse. But when we start talking about x and y's, I don't want to have to draw the picture every time. So sine is the y over the r. Oh, I got to say this though. Remembering them is tricky. So I have a weird way of remembering them. Cosine is x over r, and then tangent is y over x. So what I do to remember tangent is I kind of, if I go in order every single time, if it's always sine, then cosine, then tangent. Sine is the y over r. Cosine is the x over r, and then tangent's got to be the y over the x. So they go like in that order. That's how I remember tangent. And then these, I never memorize these. I just know these and then flip them. But I always say sine is y, because I like try to make them rhyme. They don't really rhyme, but I try to make them rhyme. So sine is y. If you have a more clever way of remembering sine is y or cosine is x, please share. Otherwise, you're going to hear me say sine is y. Sine is y. Okay. That's just what I made up. I don't know. If you have another one, let me know. That means cosine is x, and then tangent, again, is the y over the x in that same order. If we have a unit circle, so this is now a different conversation. If we have a unit circle, that means the radius is 1. If we have a unit circle, it's called a unit circle because the radius is 1. We're going to adjust all the ratios from above. If the r is 1, look in every place where there is an r, we're going to make it 1. So sine is going to be what if r is 1? Sine is going to be y. I hope that was a joke. Was that a joke? Okay. And then cosine is going to be x over 1, which is x. Tangent is going to be y over x, no r's, so tangent's still the same. And then we plug in 1 for r for the reciprocal functions. Cosecant is going to be 1 over y. Secant will be 1 over x, and tangent will be x over y. So they are still reciprocals. That's only if it's the unit circle. If it's a unit circle, you can use these. If it's any other circle, you use the ones above it. A reference angle. I think I talked about this for like a half a second before. Reference angles that people don't remember, and then this would be very easy points to get on a quiz, and then it's also really easy points to get off the quiz if you don't know it. Reference angle is always positive. It's always acute, which is between 0 and 90, not equal to 0, not equal to 90. It's always positive, it's always acute, and it's always formed by the radius and the x-axis. It's always positive, it's always acute, and it's always formed by the radius and the x-axis. This is a, actually, before we get there, the reference angle, I was just going to show a picture. Let's do a picture. Oh, actually, I didn't have to. The picture's over here. Here's reference angles. It's kind of hard to read a little bit. Didn't print out that well, but if the terminal side is in the second quadrant, look at where my reference angle is. It is formed by the radius and the x-axis. If it's in the first quadrant, my terminal side is in the first quadrant. The reference angle is formed to the x-axis with the radius. If it is in the third quadrant, if we start here and we rotate all the way around, we end in the third quadrant. The reference angle is the angle that is formed by the x-axis and the radius. If it is in the fourth quadrant, the reference angle is the one that is formed by the radius and the x-axis. It always goes to the x-axis. If you go to the y-axis, you get everything wrong. Okay? Always the x-axis. Always positive, always between 0 and 90. All right, example 1. Evaluate the 6 trigonometric functions at each real number. So I don't know why we're not using a theta. It's because the book didn't use a theta at first. So we're going to, here's my theta. The 6 trigonometric functions at each real number. So the first thing that I do is I do sine pi over 6. Sine. Nope, cosine, I mean. Pi over 6. Tangent. It's always sine of an angle. Pi over 6 is an angle. What form is pi over 6 the angle in? Like, that's radian form, right? Why? Because there's no degree sign. That is correct. So we need to figure out the sine, cosine, tan, all the trigonometric ratios of this. If we need a picture, we can go ahead and draw a picture. That's not a problem. I already know all the answers because sure, that's fine. What is pi over 6 as a degree? So I could draw. It is. How are you getting that so fast? You have it memorized, or are you thinking? 180 divided by 6? Yeah, divide by 6, yeah. Because 180 is pi, and pi divided by 6 is going to be 30 degrees. So it's at 30 degrees. I should have drawn this bigger. Let me draw this a little bit bigger. There we go. So if I don't have these numbers memorized, then I'm going to have to think about my 30, 60, 90. And my shortest side is the one that's across from 30 degrees. And the shortest side is which number? That's the 1 or the 1x. My longest side, my hypotenuse, my radius, is which side? That's the 2 or the 2x. It doesn't matter if you do 1 or 1x. It does not matter. And then that means my bottom side on my x-axis is radical 3. So we're going to do the sine of pi over 6, which is the sine of 30 degrees. What's the answer? 1/2. Yeah, that was fast. Good. Cosine is going to be adjacent over hypotenuse. It's going to be x over r. Radical 3 over 2. We're going to see these numbers so many times, you should have them memorized by the time you're done with today. Tangent is going to be the y over the x. So I look at my y up here, and I look at my x. If I put 1 over radical 3, what am I going to have to do? I have to rationalize it. So it will be radical 3 over 3. Now I'm just going to flip all three of those. So the cosecant has to be 2. The cosecant 3 over 3, I have to rationalize that one. And then the tangent is going to be radical 3 when I flip it. Okay, next one is 5 pi over 4. So sine 5 pi over 4. You know what takes the longest? Just writing this part on a quiz or test. All part for you already. So you don't have to do all that on a quiz or test. Eventually, maybe as I tweak my worksheets, maybe I can put that in the worksheets too, but I forget until I actually do it myself. And then I'm like, what a time waster. That's okay. At least you guys are going to remember to write 5 pi over 4 every single time, I hope. So now we're going to draw where 5 pi over 4 is. So 5 pi over 4. Whoa, what's going on with the calculators? We don't need those. You guys are both like, I'm ready. What's pi over 4 telling me to do? We're going to divide the top half into 4 equal sections. Top half is 180. So each of these is going to be how much? 45. But I want how many of them? So if I divided the top into 4, that means I need to go one further, and we're going to be down here. So I need to find the point that makes this a triangle. So as you are graphing from 0, 0, you would go x, then y to get there. So there's going to be my point, there's going to be my triangle. I don't actually have to write the point, but I need to go x, then y. So this is my x value. What should be my y value? 1 and 1? You're almost right, but I'll come back to that in a second. What should be my radius? Radical 2. So I said he's almost right. Can somebody tell me what's wrong with what picture I drew and the numbers, Stephanie, that I put? The y should be -1. She's half correct. The x should also be -1, shouldn't it? Right? Because we go left, then down, that's negative, then negative. If you forget negatives, you're going to get some wrong answers. So now we're going to do all 6 trigonometric ratios for that 45 degrees, for that 5 pi over 4. Excuse me. So the sine is y over hypotenuse. So we're going to have negative, it's going to be -1 over radical 2, that we did when we did 45 degrees the other day. So 2 over 2. And then we do the same thing for the cosine. It's the same radical 2 over 2. Tangent is y over x. So when I do y over x, I get -1 over -1, which becomes positive. So gotta just watch our signs. Cosecant. It's going to be negative radical 2, then secant is negative radical 2, and cotangent, if I flip 1, I still get 1. All right. So the next one is our theta is going to be 0. So if my initial side is here and my terminal side is here, we're only sitting here. That's where our ordered pair is. So when I talk about x, y, and r, is this a unit circle, or do we know? Didn't say it's a unit circle. So we don't really know. And I'm going to tell you it's not going to matter. I can even call it x and y if I want. But what would be my y value right here? Ooh, what would be my y value right here? What would be y? 0. So if x is whatever x is, y is 0. What is r? So there's a circle here. What's the radius of that circle? That was the worst circle I've ever drawn. Well, I don't know if it's 1. From here to here is how long? It's whatever x is. It could be 1. I don't know. So when we go to do sine of 0, and we go to do cosine of 0, and we go to do tangent of 0, sine is y over r. My y value is 0. My r value is x. What's 0 divided by any number? 0. When is it undefined? When we have number. Okay. That's when it's undefined. 0 on top, then it's okay. It's 0. How about cosine? Cosine is x over r. I'm just going to call it x, and my radius is also the same as x. So what's cosine going to be? What's x over x? 1. My tangent is y over x. So my y value is 0. My x value is x. What's tangent going to be? 0. So it did not even matter what x was. You can put any number in there. You can see none of my answers have an x or a y in it. Now let's flip them. Let's do cosecant, secant, and cotangent. What happens, and you can either flip 0 or you can go to the previous step. What happens when you flip y over r and you have r over y? We have x over 0. What does that mean? Undefined. And you write undefined. How about if we flip x over x? It's still 1, right? And what if we flip 0 over x? Undefined. If you ever flip a 0, it's undefined. Guess what happens if you flip an undefined? It's 0. Good. Can you try D? The same way that we just did C. I'm going to do it silently. I want you to try it to see if you can get it. If not, I'm going to be doing it as well up here. I have my radius wrong. Kind of wrong. As I was listing my x, my y, and my r, I realized something about radius. Radius is never a negative number because it's the length. Okay, so what I did was I took my x value, whatever that is, and I absolute valued it. So my radius is really just the positive of whatever that x is. So then cosecant, oh, I didn't finish these. Cosine is x. Tangent is okay, so for these, the only difference was instead of positive ones, it was negative ones because we were at a different location. It was pretty much the same other than that. Okay, I'm going to pause the video, and example 2 and example 3, we kind of just went through those, except now the like for example 2, it's a negative instead of a positive angle. And what's the difference between a negative angle or a positive angle? You'll go clockwise instead. So we'll go this way for pi over 3. Okay, but it's going to be all the same work. So I'm going to have you try some of these. And then with 3 and 4, I'm just having you sign cosine and tangent. What's special about 3 and 4? Same thing, you might be able to figure out by looking at 3, where is 13 pi over 6? How many pi over 6s are in the top half? 6 pi over 6 are in the top half. How many are in the bottom half? 6 more pi over 6. So in the whole thing, we have a total of 12 pi over 6. Where's 13 pi over 6? Yeah, we just like go again. Okay, so that's the only difference between these. So I want you guys to try example 2 and 3, and we'll compare answers after you've had a couple moments. Okay, so with this first one, again, what I do is I say, well, it's negative, and over here's pi, or this could be negative pi if I'm going the other direction. I still divide it into 3 equal sections because it says divide by 3. I'm just going the other direction. And I always convert that in my head to degrees. So 180 divided by 3 is how many degrees? 60. So I know that this is going to be a 60-degree angle. We're only doing one of them. It's going to be a 60-degree angle. So what I need to do is I need to draw a triangle. So we start at 0, 0, and we always do in our triangle x, then y, and when we come back, that becomes our r. Every single time. So I heard people asking about reference angles because we talked about those for a half a second. We will keep talking more about those, but if you draw your triangle correctly, the way that you would graph an ordered pair, you will have the correct reference angle. It will be inside of the triangle. If you're just thinking about the definition of reference angles, it has to be from the radius to the x-axis. It has to be between 0 and 90, and it has to be positive. So this checks off all of those. So we are looking at a 30, 60, 90. Now I have to find the sine, cosine, tangent, and the other 3 of 60 degrees located in the 4th quadrant. So until I have all that memorized, maybe I write in my numbers. Across from 30 degrees is the smallest side. So the 1 is going to be my x value. And then my hypotenuse is the 2. That means this side, which is y, is going to be our radical 3. Except, if I'm going down, what do we do with our radical 3? It's going to be negative. So now I go in and find my sine, cosine, tangent. Remember, sine is y over r. Cosine is x over r. Tangent is y over x. So I'm doing the sine of 60 or the sine of pi over 3, but in the 4th quadrant. That's going to be negative radical 3 over 2. The cosine is going to be 1 over 2, and that'll be positive. And then the tangent is going to be the y over the x, so negative radical 3 over 1, which I don't have to write the over 1. And then from there, I'm just going to flip those. So this one will be negative 2 radical 3 over 3. This one will be 2, and then this one will be negative radical 3 over 3. And I have those memorized of when I flip negative radical 3, it's negative radical 3 over 3. Like, I know those because I've done them so many times. Yes, dear?
Why isn't the radius negative?
Because the radius is distance or length in a circle, so it'll never be negative. Katie, I'll bring it to you, but it's for you. Okay, so the next one. We've got find sine, cosine, and tangent of the following. We don't even have to do all of it. So you guys kind of drew where you go like around one whole time, and then we went just a little bit further. And we need to figure out that that is a 30-degree angle. And so across from the 30 degrees would be the 1. The hypotenuse is the 2, so that's the radius. And then my x value is radical 3. And these are in the 1st quadrant, so they're all positive. So then I have a half, radical 3 over 2, and then radical 3 over 3 when I simplify that. And then this one, a lot of people had questions on. So I'm going negative, and I'm doing pi over 2, so that's going to be 1, 2, 3, 4, 5, 6, 7 pi over 2. So that's going to end up right here on the y-axis. So that does not have a triangle. You cannot make a triangle if it's on the y-axis or on the x-axis. There's no triangle. The only time we have triangles is if we go like over x up y. Here we're going over nothing up y. So there's not a triangle. It's just a straight line. So that means my radius is what? Is whatever y is. If it's a unit circle, you can make it 1. If it's not the unit circle, you got to make it whatever it is. So I'm just going to leave it as y. Eventually, we'll get to it where it's just a unit circle, and you just can make it 1 every single time. But we haven't done that yet. So then the sign is going to be y over r. So in my picture, y over y. So 1. The cosine is going to be x over r. So 0 over y is 0. And then the tangent is going to be y over x. So y is y, x is 0. That's undefined. If you would like an abbreviation for undefined, UNDF, there is not a symbol for undefined. I've looked it up. There's not a symbol. There should be. There's not. All right. I said we were going to take a break, but there's just like 4 graphing calculator questions. Let's do those real fast. Then we'll take a break. Okay. Okay, these are graphing calculators, so what are you going to type in? Tangent? Tangent what? Yeah, and literally use the pi. Don't use 3.14, 1596, 26, 15926. And you should get 1.7321. Is it 4 or 5? Yeah. What happens if you didn't get that? You're probably in degree mode from doing your assignment. What is this? Is that degrees? No. So we have to think ahead, and we have to tell our calculator. I actually need degree or radian mode right now, calculator. Tell your calculator that. Fix the mode, redo the question. 1.7321. Next, do we need to be in degree mode or in radian mode? Cotangent 1. Why is it radian mode? Because there's no degree symbol. Excellent. You guys are picking these things up. How do I type in cotangent, though? 1 over tangent, and then the 1 is the theta. That has to stay with the tangent. 0.6421. Okay, how about cosine? 45 degrees. Degree mode. I already know the answer to it, though. I don't even need a calculator for that. Well, it should be radical 2 over 2, but this does say a calculator in round, so I will use my calculator. 7071. If you type in radical 2 divided by 2, it should give you the exact same answer. And then secant 1.8. What mode should I be in? Radian mode. How do I type in secant? You guys are so exciting when you say those things. 1 over cosine. And I get negative, approximately, negative 4.4014. There was a hole right here. All right, break, brain break. Stand up, get out of your seat. Stop sitting there. Get out of your seat. Let's do a brain break.